we are going to be looking at another problem from Chapter 5, Section 1. This is problem number 34. The important stuff is stated up here. As I read this to you, I can increase the calculator, but it says that $35,000 is invested. That's supposed to be 4 here. T years at 9% interest compounded continuously. The future value is given by S equals 35,000 E raised to the 0.09 T. What we want to do is we first of all want to graph this function for 0 less than or equal to T less than or equal to 8. Now, when we put on our calculator, clearing out what was there, we cannot use S and T on the TI calculators. We have to use X and Y. And so on this, our independent variable is the T, our dependent variable is the S. And so our T value is going to be the equivalent to the X, and our Y value is going to be equivalent to the S. And so when we put this in the calculator, we're going to put in this 35,000. And then this is going to be times E, and then that E function is over here with the ln. So I'm going to do second E to the, and we're going to have 0.09, and here's where we put the X instead of the T. This is the function that we want to graph. They ask us to graph this from 0 to 8. So I'm going to go from 0 to 8. We can leave the scale 1. Now, for our Y values, this range is going to be quite different. We started out with 35,000, so let's have a minimum here of, say, 30,000. And for part B of this problem, we need to get to 60,000, so let's maybe just go up to 80,000. And our scale on this, let's make that, let's make it 5,000 to begin with here. And this hopefully is a good looking graph. That graph almost looks like a line, but it's not quite. Notice that it bends upward just a little bit. So this is concave upward. And I'm going to call this the end of part A. So this is the graph that we can have. If you need to turn in something with paper, you can make a copy of this. In Course Compass, you'll be doing other things. Part B of this problem asks us to use the graph to estimate when the future value will be $60,000. I am going to use a method for doing this. I'm going to put in a new equation, and I'm just going to put y equal to the constant 60,000 and add this to the graph. And so what we have here is we have the graph of the future value, and we have the graph of just 60,000. We want to know where they intersect here. So I'm going to use the calculator method using second calc for calculate, and we're going to use the intersect here. So I'm going to hit enter. And there's only 2 curves in here, so I don't have to tell the calculator which ones they are. Actually, I do. They're the first curve and the second curve. Now, if we want, we can scroll closer to our intersect point, but it's not technically necessary. And we have that the time on this, estimate when the future value will be about 60,000. We're going to have an answer of almost 6 years. And so if I rounded that off to the nearest tenth, it would be 6 years. I'm going to get my pointer option going here. And writing this in here, my answer for this particular problem, I'm going to have that the t value here is going to be equal to approximately 6.0 years. And that's a pretty good answer. That's supposed to have been an E. Okay? The next part is going to be a little more challenging. We need to complete the table here. And so on this table, we need to evaluate the different pieces of this. And so on this first one, if we had a 10 in here, what we're going to actually compute is going to be the following. I'll write the first one down. I'm not going to write the second one. This is going to be then 35,000. And then we're going to have E raised to the 0.09 times 10. And so going to the calculator, I can put in this 35,000, so let me clear out of here. I'm going to go 35,000. Then we're going to use our e to the function, and we're going to have 0.09 times 10. And we'll close the parentheses, and our answer for this one is going to be about 86,000. $86, and oops, that's supposed to be a 6, and about 11 cents. Pretty accurate answer. To do part B, I need to change the 10 to an 11. So the 10 that we have up here, I need to change that to an 11. The quick and easy way to do that is to do second entry. And now I'm going to back up, and on top of the 0, I'm going to replace it with a 5. And this gives us our next answer. So I'm going to have 135,000. And this is in dollars, but this is going to be 135,000, $9. And if you want it accurate to the nearest cent, this would be 89 cents. This next part is going to be a bit more challenging, and we do not have algebraic techniques to do this, and so this is going to have to just be an estimate. Notice that this gets a lot bigger, and notice that at 15 years we got over 135,000, but now we need to get over 253,000. So what I'm going to do is go back to the calculator, and I'm going to adjust the window so that I can see a bit more. And let's change our X max. Hopefully we can do this within 25 years. Let me change the scale to 5 so that I don't have so many tick marks. And we need to get this over 253,000, so let's make that 275,000. And now I'm going to change this over here to 50,000 so that we don't have so many little tick marks. I don't need this one here, so I'm going to clear it out. This looks like this graph now, and I think we're going to see what we need. I have to admit I played around with this before making the tape, so don't think that I just have great guesses the first time. To estimate this, we're going to use the method that we used before, and I'm going to put in that 253,496. Put that in here, and if I graph that line, once again I can use the intersect method to figure out what that t value is when the y value is at 253,496. So we'll go to second calc, and we're going to choose number 5 for intersect. And the first curve is that one. There's our second curve. If we want, we can scroll over and get a bit closer to it. I'll hit enter a third time, and lo and behold, it came in very, very nice answer of simply 22 years. And so going back here, finishing this table, this is going to be 22 years. This then finishes problem number 34 from section 5.1.